Hello everyone, welcome back to Tech with a Look. In today's session, we are going to understand one of the most important topic in Kubernetes. What is Kubernetes and why was it created? So before directly jumping onto the Kubernetes concepts like pod deployments and services, we first need to understand the problem Kubernetes was designed to solve. So without much delay, let's get begin. Let's talk about some years back. Let's consider 15 years back and we name it as a traditional deployment era. So during that time, what the companies were usually doing, so the applications directly installed onto the physical servers. Let me consider this is a physical server. All right, and within that physical server, company installs, let's say, application A, application B, the database is web server and many other libraries which supports the application. So runs in the everything runs in the same machine. So what happens at the particular time, application A receives 90% of traffic. So at the time of receiving the 90% of traffic, what will happen to the physical server? It will start consuming all the resources available in the physical server, which will definitely add an impact on the other set of services which are running in the physical server. So with that, all the other services will start responding slow. In result, database becomes slow. Your website which are running as an application B sometimes unresponsive. Users experience will delay. In simple words, I would say one application can negatively impact on all other applications running on the other servers. So let me write it down, the other problems that started coming when we were in the traditional deployment era. Let me call it as a number one for the day. So number one problem, by looking this physical server and all the application dependency databases and other set of services are running in a similar machine, we observed when the application A receives more traffic, it start consuming most of the resources from the server, and which will negatively impact on the other set of services running in this physical server. Say in the simple terms, the problem is resource conflict. So we saw in the traditional era, we saw the problem resource conflict started happening because everything was running in the physical servers. In real life example, you can relate it with one example like imagine a family sharing one water tank. If one person start using too much water, then everyone else receive less water. Similarly, server resources has shared resources. and if one of the application start consuming more set of resources, other services suffers. Now move on to the next one. In the traditional deployment era, what was the other things happening? Let's say suppose one of the application crashes, then it may affect to the other applications. Sometimes it may consume all the memory and create unexpected issues. As a result, other applications may also fall and they are failed to run ultimately. So what will happen? The entire server performance may degrade. So the second problem we saw, if one application crashes, it may affect to the other applications and may result all the physical server because fail to run, entire server performance may degrade. In real example, you can take it like imagine four shops operating inside one building. In one shop catches fire, the entire building is affected. So there is no isolation between the applications. So the second problem we saw in the traditional deployment era was lack of isolation. Next problem we also faced, suppose our application A is a e-commerce website which receives huge traffic during one of the festival season. Let's say we are in India and during Diwali sale, this application receives lot of traffic from the customers or from the end users. So only for the website need additional resources, but because everything runs together on one server, you cannot scale just one application. So instead of that, what you will do, you will need to purchase another physical server and set up everything, other libraries, applications, and similar way that you have set up for the physical server one. So in result, what will happen? That would be expensive. It could be a time consuming. Real life example, we can say imagine buying a entirely new house just because one room became crowded. So does not make sense, right? So we saw when the traffic increases on the application A, it is hard for us to scale the application or scale the number of servers because that servers are too bulky and difficult to install at that particular time. So the third problem we faced, which is difficult scaling. Now let's consider the another problem. Let's say to avoid that third problem, company initially bought many servers, many physical servers, or let's say the company bought one very heavy physical server. To avoid the outages, companies usually purchased very powerful servers. But during normal days, when the traffic is not too high, some of the CPU utilization remains unused. Memory utilization remains unused. So what the result at the end? So the companies paid for the resources they rarely used. So the fourth problem, I would say, if the company uses the physical server very heavily in the beginning, which may result the resource wastage. So with that conclusion, I would say traditional deployment worked for the small applications, but as the application becomes larger and the business grew, the company needs a better solution, and that solution was virtual machines. So we came into the second era which is the virtual machines era. Let's say, let me copy this one for speeding it up. In the virtual machines, what happens? There is a one physical server, and same physical server, we don't have a many application installed. We will install on the basis of different OS level. Let's say this physical server is designed in a way that this has many VMs. All right. So these VMs are all the VMs are running in physical server. This is a VM1, this is VM2, this is VM3. Let me do it in a way like so it would be better for understanding. VM1, VM2, and this is VM3. Let me remove everything from here, and let me do this way. The physical server is quite big. This is virtual machine 1, this is virtual machine 2, and this is virtual machine 3. In the virtual machine 1, they have their own operating system, they have their own application. Similarly, their application 2, let me name it application 1, OS1. OS2, app 2, OS3. So one physical server having the multiple virtual machines, and each virtual machines having their own application, own operating system. So the one problem that we were seeing in the traditional deployment era was lack of isolation, because if let's say one application consume all the resources, then other application affects. But in the virtual machines, there's a proper isolation between the applications. So this definitely resolves one of the problems that we faced in traditional era. So some of the benefits that we see here in the traditional area was benefits of virtual machines. Let's write it down here so that whenever you guys will be seeing at your personal time, so that you can just relate the things while watching this video. So I would say the applications are separated. The applications are separated because of better isolation, and I would say the better security as well, because we cannot interfere one application to another application easily. So I would say better security as well. And one physical server can host multiple VMs, so that ultimately reduce some of the resources cost. So one of the resources cost as well. So if you see in the virtual machines era, have couple of benefits which definitely helps to the application owners to deploy in a better way, but this also leads with some of the problems. New problems arises when the virtual machine started coming. Let's discuss those first. If we are using virtual one physical server, one very big physical server, and every virtual machine has their own operating systems, ultimately the effect on the physical server will be very heavy, right? Because the full operating system is to come up with a full operating system in every virtual machine leads to a very heavy weight on the physical server. So ultimately, one problem we saw here, that the heavy weight, another way you can consume GB plus 2 GB plus 2 GB becomes 6 GB only for operating systems. That is huge overhead. In real life example, imagine you are carrying 3 suitcases and each containing the same clothes. So lot of duplicacy happens. The second problem we saw in the virtual machines, booting a virtual machine is similar to booting a complex computer. It may take 1 minute, 2 minutes, and couple of more minutes as well. But modern application requires faster deployment. So the second problem we saw, slow startup. The third problem we saw was the resource consumption. Each VM consumes CPU, RAM, storages. As the number of VMs increases, infrastructure cost also increase. So resource consumption also increased here. The one more important point, as the traffic increases for one of the application, creating new VM takes time. An application cannot instantly scale it automatically. So I would say the poor scalability. With that conclusion, I would say virtual machines definitely solved some of the problems that we were facing in traditional deployment era, but they were still heavy and inefficient. This led to the new era, which we will call as a containers. Containers definitely became extremely popular because they are lightweight. If I would say this is one physical server, and on the top of it it requires only one operating system, and on the top of the operating system let me just do it in a better way so that it will help you to understand. In one OS, all right, and within one OS we have Docker engine, because containers, whenever we talk about the containers, we will be talking about the Docker. And within the container Docker engine, we have containers. Let me write container 1, container 2, and container 3. Let me make small gaps in between because they all are isolated. Alright, so if you see one physical server, one OS, just to install Docker engine on the top of it, and we can spin up multiple containers. And they are quite lightweighted as well. And within the containers, we can run the application by installing some libraries or the dependencies of it, and this will be keep running. So the benefits of the container, I would say, let me write it down here. Benefit of containers. Containers are the lightweighted, and the one problem that we were facing in the virtual machines, that they were quite heavyweight, but container does not have the operating system, does not have the operating system, and only having the libraries of the app. So they, because of that, they have the faster startup time. And one important thing is, whenever we make an image for a container to run our application, we can ship it to anywhere. So definitely we can launch it into the any environment. Let's say if it is running on the one physical server and we have another physical server, we can just ship the image of this container to there and we can just run it. So it helps us. So I would say it's a faster deployment as well as portability. So definitely it helps in the portability. And one of the common problems that we saw earlier in the virtual machines era, when sometimes the developers say the code is working and the application is running fine in his local machine, but whenever we deploy that particular application or the new build into the production environment, then the developer does not know why it is failing. So it works on my machine, it means it will work everywhere. We just have to install the dependencies there for the application. All right, so these are the benefits, but some challenges also started coming when we started using the containers. Some challenges, I would write it here. Like, let's say we have 100 applications running in one of the company, in one of the environment. To run the 100 containers, and who will manage those set of containers. So management of the containers became a challenge. Now the second problem we saw, if one of the containers fail, suppose one container crashes, and who will start it? Should an engineer manually monitor every container? Which is impossible. So the container failure there. Now the third problem that we faced, when the traffic increases, who creates additional containers? Traffic decreases, who will remove the unnecessary containers? So manual scaling is difficult. So I would say in containers the manual scaling is difficult. The next problem definitely we faced, which was related to the containers only. Let's say suppose 10 containers are running, how we can distribute the traffic among all the containers equally. So the proper distribution is missing in the containers. So the some containers become overloaded and some containers become idle. So I would say the challenge that we were facing in the distribution, low distributions. Let's say one of the machine goes down. Let's say this physical server on which all the containers are running. Let's say this machine itself goes down. What happens to all the containers? So all the application running inside the containers becomes unavailable. So the server failure. The next problem that we, or the challenge that we faced in the containers are, suppose we need to update the application with another version. How do you deploy it without affecting the end user? So downtime is unacceptable for the production application. So we face the updates, another challenge. So in the conclusion, I would say containers solved many problems, many virtual machines problems, but managing containers manually became a nightmare. Companies needed a platform that could deploy containers, monitor containers, or restart failed containers, scale automatically whenever the load increases, perform updates without downtime. And to resolve these kind of challenges, the new platform or the new technology came in the market, which was Kubernetes. So Kubernetes is a open source container orchestration platform. That's a definition that you will see anywhere if you write it down, Kubernetes. So you will see the open source container orchestration platform. It automates deployment, scaling, management, but you will not understand this until you will do the hands-on. So before going on to the hands-on session, the best way to remember the Kubernetes is a manager of containers. So Kubernetes is the manager of containers, and it automatically handles deployment, scaling, load balancing, self-healing, rolling updates, and high availability, which we were facing the issues in the container. So the all challenges that we were facing here automatically resolves in Kubernetes. The Google faced a similar challenge in their environment, because in the Google, they run their own services like Gmail service, YouTube service, Maps, and Google search. So million of containers were running, but Google already had an internal system called Borg, which we are calling as a Borg. Based on the years of experience on the Borg, they have officially released this version for the public. So in 2014 they released it, and they are calling as a Kubernetes in the market. Now it is maintained by CNCF, which is Cloud Native Computing Foundation. All right. So this is how the Kubernetes born in 2014. So the overall purpose of this video is to help you to understand not only the Kubernetes is, but more importantly why it was created. So in the next video we will dive deeper into containers versus virtual machines. So for now I would stop myself for this session, and if you enjoyed this session, please like the video and subscribe to Tech with Alok. Thank you for watching, and I will see you in the next session.